It's threatening marine life.
These deep-sea coral reefs are like a block of towers. We're removing the bricks from the bottom of these ecosystems
And putting human livelihoods in peril.
By having more carbon dioxide in the water, it's slowly killing the ocean.
But it's not climate change. It's been dubbed climate change's evil twin, ocean acidification.
The point at which we could have avoided the worst of this car crash, I'm afraid, is over.
So how serious is this threat, bubbling below the surface?
It's a rush against time to stop this.
And what can be done to tackle it? Vanessa O'Brien is an explorer who has been to space and the summit of Mount Everest. In 2020, she set out to become the first woman to reach both the highest point on Earth and the deepest part of the ocean.
I was going to the most extreme environment on the planet in a reusable submersible. The longer we're down, the more likely things go wrong. What motivates me personally to be part of something bigger than myself, to contribute to wider knowledge or inspire even one person.
After 4 hours, Vanessa successfully reached the very bottom of the Pacific Ocean, an area called the Challenger Deep, nearly 11,000 meters below the surface. Part of her mission was to collect samples to allow scientists to do further research into a problem many people have never heard of, but which Vanessa had read about: ocean acidification.
I chose to give my water samples to the Natural History Museum because it was their article on ocean acidification that inspired me.
In 2020, scientists at London's Natural History Museum published a paper on the rising acidification of the ocean since the Industrial Revolution and the impact of this on marine life. They studied shelled creatures collected from the Pacific Ocean in 1875 by a ship named HMS Challenger. Then, the scientists compared these historical samples to modern versions of the same organisms, collected nearly 150 years later in the same area.
What we've seen is that some of these organisms, their shells have been up to 76% thinner in the modern day than they were at the time of the Challenger. So our conclusion was that the thinning of these shells over 150 years was an example of one of the products of ocean acidification.
So what exactly is ocean acidification, and how worrying is it? The best place to start is Washington State, in the early 2000s, when oyster farmers were mysteriously losing huge amounts of stock from their hatcheries.
Over 3/4 of our oyster larvae died, so it's a big impact for us.
And the impact is being felt by the local economy that depends on their business.
This high rate of mortality at first was a mystery. Could it be pollution? Could it be climate change?
Then scientists discovered the cause. The changing chemistry of the ocean was preventing baby oysters from making shells. It was the first time ocean acidification was identified as a threat to marine life.
Washington State, where I live, has the dubious distinction of being ground zero for ocean acidification. Ocean acidification has literally changed the chemistry of our oceans.
What's happening now is at a scale and at a speed which is just unprecedented. And it means that we're living in the first ocean acidification experiment at this speed, which is truly terrifying.
Ocean acidification is alarming, but it's not exactly what it sounds like. Acidity is measured by the pH scale. In the middle is neutral, 7. Anything lower is acidic. Anything higher is the opposite, alkaline. The ocean's pH level is around 8, meaning it's actually alkaline, not acidic. Since the Industrial Revolution, the ocean's pH level has decreased from 8.2 to around 8.05. This drop may sound small, but it has a vast reach. It equates to an increase in acidity of around 40%, shown on this map as a shift from blue to yellow. And by the end of this century, the ocean is predicted to be 150% more acidic. Small wonder scientists are concerned.
I have 2 children. I would love for them to know about the oceans in their science and geography lessons, but if we keep on going the way we're going with ocean acidification, climate change, then my fear is that they will end up having to learn about these things in history lessons.
So what's driving this? There's a familiar culprit, the carbon dioxide created by burning fossil fuels. As the amount of CO2 in our atmosphere increases, the ocean's pH level decreases. This chemical change in the ocean makes life much harder for many marine animals.
Carbon dioxide is such an important player in many of the key processes that just a small change in ocean chemistry can have huge implications for the health of individual organisms and for whole ecosystems.
Dr. Sebastian Henniger is a leading global expert on ocean acidification and studies its impact on coral across the world. His research suggests ocean acidification is the prime suspect in the destruction of deep, cold water coral, which is essential to the marine ecosystem.
One of the main reasons they're important is that they support just a huge amount of biodiversity. And without those, there just would be less life in those areas and less life which then feeds up into the different food chains as well.
If the coral collapses, homes for other animals are lost and ecosystems threatened.
You can really see how complex the framework is here.
His forensic investigations suggest ocean acidification is the cause of a threatening condition called coral porosis.
Osteoporosis in humans is when we start getting more holes in our bones. We call this coral porosis because this is porosis, or dissolution, of the coral itself.
In California, coral porosis has caused these corals to collapse and crumble. The disease first attacks the dead coral skeletons on which the living coral is anchored.
These reefs are built of mostly dead coral skeleton with the live coral continuously growing upwards. They tower up to tens of meters high. So these deep sea coral ecosystems are really cities of the deep. They're supporting all sorts of other life. If that dead part starts to dissolve, then that whole ecosystem starts to collapse.
Sebastian says studying California's collapsed reefs could give clues about the fate of deep sea coral in other parts of the ocean.
We're very interested in looking at the Californian coral systems because it is a window into our future.
Another challenge for scientists is understanding how the threat of ocean acidification is combining with climate change.
So if we can check the pH from these samples today.
So now, at his lab in Scotland, Sebastian is exposing deep sea coral to more acidified, warmer waters and decreased oxygen, with results expected in autumn 2023.
We can put these corals in these tanks and simulate future ocean conditions. And by doing that, we can see the timescales that we'll see for collapses of ecosystems as a whole. With marine ecosystems, they're going to become hotter, they're going to become more sour as we increase the CO2, and they're going to become breathless as we decrease the oxygen which is available to marine life.
This threat to marine ecosystems also poses a threat to human livelihoods across the world, from scallop fishermen in Peru to the indigenous people of Alaska who rely on salmon.
I've always been taught that when the tide is out, the table is set.
Raven Cunningham is a 6th-generation commercial fisherman who has noticed a worrying change.
We would go out and harvest shellfish. We would be able to go get a 5-gallon bucket in a couple hours. Just this spring, I went out for half the day and only got a quarter of a bucket.
Raven is an Eyak-Chugach, Alaska native. The Eyak indigenous community have been living in southern Alaska for over 3,000 years. The sea has always been central to their way of life, but more recently, both have been severely threatened.
The devastating environmental and economic effects of this spill are going to be here for many years.
In 1989, the Exxon Valdez tanker spilled over 41 million litres of crude oil. And the impact continues to be felt now. ocean acidification is another, less conspicuous, but increasingly serious threat to Raven and her community.
My community is very dependent on the ocean, not only for economic benefits, but for subsistence. Everybody in our community subsists in one way or another.
The Eyak depend on salmon especially. Much like the rest of Alaska, where salmon accounts for more than a third of its seafood industry, worth over $5 billion. It's now feared ocean acidification is contributing to declines in both the numbers and size of salmon.
Our Copper River king salmon would come around 50 to 100 pounds. Now we're lucky if we catch 30 to 50 pound salmon.
Ocean acidification could be one of the causes of this decline because it is killing the food source salmon rely on. These small creatures called pteropods.
Pteropods are the original poster child of ocean acidification. They're tiny planktonic snails that literally everybody loves to eat.
These protein-packed power bars are known as the potato chips of the sea. Found all over the world, they're eaten by everything from salmon to seabirds. So these tiny creatures can have a huge impact, not just on ocean life, but on the entire food chain.
We quite often call them sea butterflies because they kind of have this flying wing movement. They're very beautiful creatures, it looks nice and healthy. It's obviously very active, it's moving around a lot, we can't keep the camera on it.
But now, the shells of this vital species are dissolving in waters all over the world. And with around 40% of the global population relying on seafood as a significant source of protein, there are concerns about the impact on the world's food supply chain.
You can see all around the edges here, there's cracking and a great big hole here. Pteropods are now being found around the oceans, around different locations around the world, in different states of this sort of dissolution. And these are indicators that oceanification is happening out there in the real world.
So what can be done to tackle ocean acidification? Well, the most effective answer is one you've probably heard many times before.
Reduce our carbon dioxide emissions.
Reduce.
We need to stop putting carbon dioxide into the atmosphere.
Reducing fossil fuel consumption remains the single most important measure. But there are other things which can help deal with the carbon dissolved in the ocean. Growing plants like seagrass or kelp under the water is one. They are very effective at absorbing carbon. Seagrass captures carbon 35 times faster than tropical rainforests. But there are clear limitations.
To really mitigate today's carbon dioxide emissions, you'd have to carpet a fair portion of the world's oceans with seaweed farms.
Others, such as this company in West London, are putting their faith in technology.
We just came back from Hawaii, where we've built the world's first ocean-assisted direct air carbon capture plant. That's capturing around 37 tons of CO2 per year at a levelized cost of $475 per ton.
Capturing carbon dioxide from the air is a well-established idea. But Heimdall's technology is novel, capturing it from the sea. The company is targeting the ocean because it contains more carbon dioxide in the atmosphere.
We use the ocean as our intermediary in order to capture CO2, because the ocean has 150 times more CO2 in it by volume than the atmosphere does.
Heimdall has some fairly lofty ambitions. Remember the ocean's pH levels from the 1870s, when the ship HMS Challenger collected samples? Heimdall is hoping to bring those levels back.
We are restoring the pH back to the level that it was pre-industrial revolution. We are going to restore life back to our oceans.
And the company says its system, designed to sit inside a standard container, is scalable. It will need to be. Even once these containers are finalised, to capture just 1 year's worth of global CO2 emissions at current rates would take around 36 million units. From new technology to growing plants underwater, these proposed measures to tackle ocean acidification are hampered by an inconvenient truth. Reducing the volume of carbon in the ocean will have limited impact without reducing the volume in the atmosphere. You can't get away from the fact that, like climate change, ocean acidification is the result of carbon emissions. And it's just one more reason to tackle what many regard as the world's most pressing problem.
The point at which we could have avoided the worst of this car crash, I'm afraid, is over. We need to actually start applying the brakes. The big question is, how do we make this crash survivable? One that we can walk away from.